Hi guys, welcome to our content for day 2. So today in class we went through variables and we went through graphing. And tomorrow's big topic, we have 2 topics. We're going to be looking at systems of equations as well as ratios, proportions, and percents. So right now we're on day 2. We are on page 15 in the notes packet, your week 1 course packet, which is online, right? So you should be able to access that online through Schoology. If you're having trouble, just shout out to me through an email and I can help you out with that. But right now we're going to do day 2 topics. We're only doing the notes. Remember, tomorrow we're going to be working on the practice problems together. Today was the only day that we're really doing notes and practice all together because I couldn't give you guys homework before we started the course. But from now on, you're going to be watching the videos and then we're going to do practice together in class. Okay, so day 2, algebra, we're going to be looking at systems of equations. And this is a topic that oftentimes some of my students know a lot about, systems of equations, and some of my students know very little, depending on what age you are, right, what grade you're in, where you are in school. So feel free if you have seen a lot of systems of equations, if you want to try and start some of the problems, and if those feel good, right, you can try and do some of the harder problems in the notes. Tomorrow I will have some challenge problems in class that will go past the red level practice problems. So some of you guys may have never seen them before. So I'm going to really be focusing on for those who have never seen a system of equation before and walking you guys through it. So oftentimes it's necessary to write down 2 or more equations to represent a relationship between variables. Oftentimes in real life scenarios, one variable is not enough to represent a situation. So solving for the variables in these equations is called solving a system of equations. There are 2 common techniques that are used when solving a system of equations. They're called substitution as well as elimination. And we're first going to look at, just before we look at solving a system, here are some simpler ideas of what you might think of as substituting something. And I like to think about this as in sports, when we substitute for a player, what that means. So here's a really easy example of substitution. Evaluate 2a minus 5b plus c when a is 4, b is negative 2, and c is 3. So all they want you to do is substitute in 4, negative 2, and 3 for the letters a, b, and c. So that would become 2 times 4 minus 5 times our b value, which is negative 2, plus c, which is 3. And we're just going to simplify. So 8, 2 negatives make a positive 10, plus 3. Okay, and then we have 18, 19, 20, 21 it looks like. So that's just the simple idea of just what it means to substitute. And we're going to be building on this as we look at what it means to solve a system of equations with substitution. Here's another great example of just substituting. What is the value of x in the equation? Y equals 2x minus 7 when y equals 5. So we're going to substitute in a 5 for y and set that equal to 2x minus 7. And the question is, what value of x when I plug it in times 2 minus 7 will give me a 5? And this we can solve using our solving method. So we're going to try and isolate the x. So add 7 to both sides. Okay, 12 is equal to 2x, divide by 2, and x is equal to 6. Just a reminder, if you've seen these ideas before, you can just try them on your own. You don't have to go along with me. You can fast forward if some of these concepts you've seen before. So remember, this is assuming that you know absolutely nothing. I'm just walking you through it. Feel free to go at your own pace. Okay, so here's an example of what we mean when we solve by substitution. So here are 2 equations. 2 equations with 2 variables. That is what represents a system, and our 2 variables are x and y. So solving the system of equations by substitution means one of our equations, if it's, x equals something or y equals something, that's kind of your marker that substituting is easier. Because what we're going to do is we're going to take equation 1, which is y minus 2x equals 4, and instead of using x, we're going to say, okay, well, we know from equation 2 that x is exactly the same as a y minus 5. So what I'm going to do is I'm going to take away the x. and I'm going to substitute in, let's put it like that, with a different color. X is the same thing as y, take away 5. So remember, this is representing our x, and now what you'll notice is we only have one variable in our equation, and we could solve for what y is equal to. So let's solve for y. We have a -2 times everything in parentheses, so we're going to have to distribute that -2. So y minus 2y, two negatives make a positive 10, is equal to 4. Now I can combine these like terms. Notice if it's just a plain y, you can put a 1 in front, right? So 1y minus 2y is -1y plus 10 equals 4. If I subtract 10 on both sides, we're going to get that -1y is equal to -6. Right? If I divide both sides by -1 or multiply both sides, either way, you'll get that y is equal to 6. And from here, I can actually solve for what x is equal to, because if I take this information and put it together with this information, right, I can plug in and say, okay, well, x is then going to be our y value, which is 6, take away 5, which is 1. And oftentimes when we write our answers, we'll write it as x comma y is equal to 1 comma 6. That's how a lot of times we write it. And that's because another way that you can think about this concept, solving a system, right here what you're seeing is an algebraic idea. However, if I was to graph those two lines, right, these two are linear lines, you could make a table and find points, right, and you would be plotting two lines. And if I graph those two lines, it's where two lines intersect. So the point 1 comma 6 on a graph, right, if you were to visualize 1 comma 1, 2, 3, 4, 5, 6, this point is going to be where the two lines intersect, right? They might be going like this or, you know, what have you. But those two lines are going to be intersecting at that one specific point. That's the one point where x and y are exactly the same for both of your equations. Okay, so let's look at some more examples of how to solve a substitution. And what we have here, number 2, this is really common in competitions, to not just ask you to solve for x or solve for y, but to do something a step further, to find what is x plus y. So you really want to make sure if they put something like this in the directions, I oftentimes write x plus y equals blank to remind myself at the very end I have to do an extra little step. So that's just a good strategy I found. So I'm seeing two equations, two variables. I know I can use my system of equations strategy of substitution. However, remember how I said before in number 1 that it was really nice because we had x was equal to blank. Neither of these are x is equal to blank or y is equal to blank. But if I do a quick rearranging and I add 2y on both sides for this equation, I get x equals 2y take away 4. And that means I can substitute in 2y take away 4 as x in the first equation. So I'm going to write that out. I'm going to say 2y minus 4, right? We're going to call that like our x. And we're going to say that plus 3y equals 4. And now notice the only variable I have are y. So I can easily solve for what y is equal to. So let's see. 2y take away 4 plus 3y equals 4. Notice there's no distribution in this one. There's no coefficient like the first example. Combining my like terms, I have 5y's take away 4 equals 4. If I add 4 to both sides, I have 5y's are equal to 8. So y is equal to 8 over 5. And you can just leave it as 8 over 5. If you want to write it as a decimal, you can. Either way is really fine with me. I don't have a strong preference. So you could say or y is equal to 1.6. You don't have to write it as a mixed number, though. Some people really like writing it as mixed numbers. Whatever way you want to write it is fine with me, though. So I'm fine with this. I'm fine with 1 3/5. Okay, either way is fine. From here, you want to find what x is equal to. We're going to put our information of what's y together with the substitution. So x is equal to 2 times y. I'm going to use the 1.6 just to make it a little easier. And then take away 4. So on my calculator, I'm just doing times 2 minus 4. And it looks like x is equal to negative 0.8. Okay. But, quick reminder, look at the directions. We need to find x plus y. So negative 0.8 plus our y value, which is 1.6, which is equal to 0.8, a positive 0.8. So make sure that you use that suggestion because that will save you some time in the future. Okay? And then there's an example problem number 3, solving with substitution. I want you to try this one on your own if you've been following along with me and you've not seen substitution before. So what I'm going to do is I'm going to pause the video and I want you to try it on your own and then unpause when you're ready to look through the answer with me. Okay, here is the answer for number 3. So go ahead and check your work. I took the first equation and isolated our x just to have a positive coefficient. I didn't want to have a negative y and have to deal with that. And then I substituted that in, found y was equal to -3, took those two pieces of information together, the y value as well as the isolated equation, the x equals, and I plugged in y to find what x was. Okay? If you substituted a different way, you should still get the exact same answer. Remember, we want to try and write our answer as x comma y because it's really representing a point where two lines are crossing if you were to graph the information out. So now we're going to move to our second way of solving systems. Okay, so this is like big idea number 2. First one was solving with substitution. So solving a system with elimination. And I've got the steps kind of here on the side just for reference. And I'm going to write out my equations just over here like this. So here are your steps. First step is you want to make the coefficients of one of your variables, either x or y, the same value in both equations. And generally it's helpful to be opposites, because you can add or you can subtract the two equations together. So what they're just saying is we're allowed to add two equations. So looking at this, notice there's a -1y and a positive 1y. So we've already satisfied number 1. To do number 2, we're going to add them together. So 2x's plus 1x is 3x's. Notice this is a positive 1y and a negative 1y, those go away, so those cancel out. Is equal to 5 and 1 makes 6. So this is saying that 3x's is equal to 6. And now I can solve. I'm going to try and solve in a different color so you guys can see my steps. So solving, I'll make green, divide by 3, and x is equal to 2. And then we're going to substitute that value that we found for x and then find what y is. So I'm going to make that my blue step. I'm going to take maybe my first equation that x minus y is equal to 5. And I'll say, okay, well, x is 2 minus y is equal to 5. If I add 2 to both, or subtract 2, excuse me, to both sides, I get negative y is equal to 3, which means that positive y is equal to -3 if we flip-flop them. Okay. And that means our answer, x, y is equal to x is 2, y is -3. So the big idea here, I would say, is this right here. Right there, that step. The fact that we can add the equations together. And notice when we added them, they were nicely made where the y's canceled each other out. Sometimes you have to make that happen. Sometimes it's not perfectly created where the problem is able to do what we've just done. Okay, so I just want to point that out. Let's try another one just as you're getting used to this. So this one, notice, if I look at my coefficients of, oops, I wanted to highlight that. If I look at my coefficients of x, my coefficients of y, none of them are matching. So this is an example. This equation, the system, would be really hard to try and do substitution because I would have to try and isolate an x or y and I'd have to move stuff around, divide both sides by 3, and it wouldn't really be super clean. The last one that we did was, if I could scroll, there we go. The last one that I did, number 4, was actually one that you could do either way because it wouldn't be too bad to do substitution and get like this x alone or this y alone. Okay, so it's kind of up to your decision. Some people prefer one method versus another. So to solve this one, we're going to have to adjust our coefficients. So what I want to do is I want to make my coefficients match and one be positive and one be negative. So I'm going to take my first equation and I want to make them maybe both 6. So I'm going to do that times 2. My bottom one, I want to make the 2 into a 6, so I need a -3 if I want one to be positive and one to be negative.